In continuation with the previous class, I am going to discuss the numericals problem related with the all formulas of the several laws of motion. So I revise this formula again. So you have to remember the inertia, you have to remember the momentum, you have to remember the force and force along x, y and z components, and impulse. You should know conservation of momentum, linear momentum, elastic collision, non-elastic collision, recoil velocity, all the things you have to revise. So now see, I am going to discuss the numericals problem. Suppose, so your question will be like this. Question number 1, which of the following formula represent Newton's second law? So which of the following relation is the Newton's second law? Newton's second law. Option A, it is given F is equal to ma. Option B, it is given F is equal to m by e. Option C, it is given F is equal to m square by e. And here D, you remember none of the above. So this formula already I have given to you. This is a Newton's second law, already I have given. So here representation of physical significance of the formula already you know. F means force here, m means mass of the body, and a means acceleration. So that is why the first formula will be the correct option. That means which of the following relation is the Newton's second law? So F is equal to ma is the Newton's second law. Now I am going to discuss one numericals problem related with this. So how we can solve the numericals problem related with the F is equal to ma. So question number 1, now you see question number 2. Suppose a constant force is constant force F is equal to I cap plus 2 j cap Newton. A constant force F is equal to I cap plus 2 j cap Newton is acting on a body of mass 3 kg. So what will be the acceleration of the body due to the force? So the acceleration of the body due to the force is option A, suppose 5 Newton, option B 10 Newton, option C 15 Newton, and option D none of the above. Now see, according to our question here given a constant force, the value of force it is given F is equal to I cap plus 2 j cap Newton, and mass of the body it is given 3 kg. So the acceleration of the body due to the force will be. Now see how we can solve this one. So solution, you can see. So here force is given. So F is equal to, the value of F it is given I cap plus 2 j cap. And here mass it is given 3 kg. We need to calculate the value of acceleration. So if it is given like this, normal formula already you know, F is equal to me, but here given in terms of I cap j cap, so that means in vector form it is given. So you can take modulus F is equal to under root 1 square plus 2 square, it will be root 5. So root 5 means it will be 2.3. So 2.3 is the Newton. Therefore we know that we know that F is equal to ma. So when F is equal to ma, we have to calculate the value of A. So F by m. So the value of F, it is given 2.3 divided by m. M means 3 kg. So ultimately 23 by 3, and here 10, it will be like this. So around it will be suppose 30, and here 23. So question, so here we can write suppose 8, so it will be approx 7, that means approx 0.75 meter per second square. So in this way we can calculate the acceleration. So one more question is very important here, I am going to discuss. You can see, suppose the question is given like this. So here one question is given, a hammer of mass 1 kg. Question, a hammer of mass 1 kg, it is given. A hammer of mass 1 kg moving with a speed of, is moving with a speed of, 6 meter per second. 6 meter per second. It strikes a wall. Strikes a wall and comes to rest in 0.1 second. So to rest in 0.1 second. Calculate a number. You can see, calculate number 1 here, impulse of the force. Impulse of the force, number 1. And number V, you can see average retarding force. Average retarding force, that means negative acceleration, average retarding force. And number C, average retardation of the hammer. Average retardation of the hammer. So in these questions I have given 3 questions. One is impulse of the force, number B here given average or retarding force, and third number average or retardation of the hammer. So in this case you can see a hammer of mass 1 kg. So how we can solve? So first you see a number, solution a number. So here given a hammer of mass 1 kg. So mass of the hammer, it is given 1 kg. That means m is equal to 1 kg, it is given. So when m is equal to 1 kg is given, and one more thing you remember, initial velocity will be 0, final velocity 6 meter per second. So normally what is the formula we can use? I is equal to F into T. So we can write F means mv minus u. So in this case m means 1 kg, and here you can see here initial velocity, that means your final velocity. Yes, it will be 6. Now initial velocity is 6 meter per second and final velocity is 0. So in this case you can see we can write v minus u, that means 1. V means will be 0 here, minus 6. So it will be minus 6. So minus 6 Newton second. So minus 6 Newton second is the impulse of the force. that means impulsive force. So you write this one, everyone. Very simple questions here given. Sometimes it is related with the questions given to in your entrance exam. That means which of the following relation is correct for impulse? So it will be given different types of formula. I is equal to mb minus u. Maybe it may be given I is equal to mb minus m by v. So different way they can give. So second number questions, average retarding. So when we are talking about the average retarding, you remember B number force, F is equal to, so normal formula we can say F is equal to impulse divided by time. So impulse already we have calculated, that means minus 6 is there, and time it is given, the second question's time it is given 0.1. So it will be minus 60, it will be minus 60, so minus 60 Newton. So average retarding, when we are talking about the retarding, you remember retarding means negative. So that is why we can write this value F is equal to minus 60 Newton is the retarding force. Number third, average retardation of the hammer. Average retardation of the hammer, it will be that means we have to average retardation, that means we have to calculate the value of average acceleration. That means C number, we know that F is equal to ma, A is equal to F by m. So here retardation force it is given 60 and mass it is given 1 kg. So it will be 60 divided by 1 is equal to 60 meter per second square. So retardation will be 60 meter per second square, you remember. So question number 1, a hammer of mass 1 kg is moving with a speed of 6 meter per second. So this is the answer for you. So in this way you can easily calculate the value of different questions. Okay. Now see, suppose you have given impulsive force. Impulsive force means this is a kind of force for short duration of time. Force developed for short duration of time. Impulsive force. So you can see here I am talking about the impulsive, so I is equal to F into T. So you remember force also we can write I is equal to F into T, we can write. Suppose I am giving one question to you, a force acting, that means a force, we can give a force F is equal to twice T square plus 6 Newton acting on a body. So here you can see a force F is equal to 2 T square plus 6 Newton acting on a body. What will be the impulse? What will be the impulse for the time interval, 0 to 1 second. So we have to, what will be the impulse? What will be the impulse for the time interval 0 to 1 second? Now how we can proceed the solution from the given question? So already we know I is equal to F into T, it is given. So this formula we can write, F into dt also we can write. So here integration we can give, and time interval given 0 to 1. So we can write like this. So the value of force it is given 2t square plus 6 here dt and 0 to 1. So in this case we can write 2, it will be 3 by 3 plus 6t. So we can write like this, direct solution 0. So that is why all the students, you remember, you have to check the previous class in which I discussed about the basics of physics, in which differentiation I discussed, in which vectors discussed, integration discussed. So all the part you have to check it. So according to the rule of integrations, this can be written as 2 by 3 into 1 cube plus 6 into 1 minus all the term is 0, so it will be 0. So ultimately 2 by 3 plus 6, so it will be 20 by 3, 6.6, 6.6 Newton second. So 6.6 Newton second is the impulse of the particles. This is the impulse. So in this way we can easily find, or we can easily calculate the impulse. Suppose one more question it is given, another question. The question is like this. You can see, suppose displacement of a particle it is given. Suppose displacement of a particle, displacement of a particle is represented by, it is given y is equal to ut plus half gt square meters. So from the given relations we have to calculate what will be the, or what is the force, what is the force of the particle, what is the force of the particle. That means we have to calculate the force of the particle. Here you can see the displacement of the particle, it is given y is equal to ut plus half gt square. So in this case what we will do, you have to differentiate it. So solution, you can see here solution. So y is equal to, it is given ut plus half gt square. So this formula it is given, the displacement it is given. So differentiate it, dy by dt is equal to, it will be u plus half z into twice t. So dy by dt means this is a velocity. We can write u plus zt because 2 to cancel. So again differentiate it because we need to find the value of acceleration. So it will be dv by dt is equal to, we can write here 0 plus z. So acceleration is equal to z. So therefore you remember we have to calculate the value of what is the force. We have to calculate the force of the particle. So therefore force will be F is equal to me. Already you know force F is equal to me. So in this case, if the mass of the particle is m and acceleration it is given z, so the total force will be mg. So this is the formula. So dear students, you have to memorize, you have to remember, you have to practice it, how we can find the force. So first you have to determine, here displacement is given. So from the given displacement, how we can calculate the value of force. So normally the formula is force F is equal to ma. A means acceleration due to gravity. So here F is equal to ma. So m means mass of the particles, a means acceleration of the particles. So therefore this acceleration of the particles, to calculate the acceleration of the particles, you must know the differentiation. You have to calculate the first differentiation after the second differentiation. After doing the second differentiation, you can easily calculate the value of force. So this is the idea, F is equal to mg. In this way we can easily calculate the value of force. Now see, when we are talking about your that means two-dimensional collision, elastic collision, one-dimensional elastic collision, one-dimensional elastic collision, at the time you have to remember this all formula. That means conservation, angular conservation, linear conservation, that means linear momentum, you should know. So first, you see, in this case, I am going to discuss, suppose angular momentum, already you know the angular momentum and torque. So basically there is some relation. So you can write important relation, important relations. So you have to remember some important relation. So number one, you remember momentum, basically we know that mv. So here m means mass, b means velocity, p means momentum. Number two, angular momentum L is equal to mvr. This is a kind of formula related with the angular momentum. Number three, you remember there is a formula momentum, linear momentum, and here you see moment of inertia mr square. You remember this is a moment of inertia. So moment of inertia, this is a formula. I means moment of inertia, m means mass, and square distance. Number four, here you can see L is equal to R cross P. This is also a kind of formula. L is equal to R cross P. This is a kind of formula. Now number five, L is equal to R cross P, and number five you can see tau is equal to dL by dt. There is a formula. So this is a torque is equal to dL by dt. So here already you know L means angular momentum. So rate of change of angular momentum, it is also called torque. So rate of change of angular momentum is torque. So torque can be expressed tau is equal to dL by dt. So again you can see conservation of angular momentum, already you know. Conservation of linear momentum constant, and angular momentum it will be L is equal to constant. So these are the formula you have to remember. Again you can see there is one formula, number 8. E is equal to half I omega square formula. So here this E means rotational kinetic energy, and here moment of inertia, and here omega. Number 9, tau is equal to I alpha. This is also a kind of formula. Torque is here. Torque is equal to moment of inertia and angular acceleration. So torque is equal to moment of inertia and angular acceleration. Now see, these are the formula you have to remember, and you can easily solve the numericals related with this. So for example, I am discussing one question. Suppose you can see the angular momentum. The question is the angular momentum of a particle. The angular momentum of a particle is represented by so the angular momentum is represented by L is equal to twice t square plus 9 kg meter square per second. So what will be the torque? Find the torque at half second. So find the torque at half second. So you just see which formula we can use here. So here you can see torque and angular momentum, it is related with this formula. Here L is equal to given 2t square plus 9 kg meter square per second. So you remember the unit. After knowing the unit, you can easily find the quantity, basically which quantity basically represent angular momentum or linear momentum or any other thing. So depending upon the unit you can calculate. Now see solution. So L is given, that means angular momentum is given 2t square plus 9. But we have to calculate, find the torque at half second. So torque means already you know dl divided by dt is equal to 4t plus 0. So dl by dt means torque, it will be 40. So according to our questions, we have to calculate the value of torque at at half second. Therefore, t is equal to 4 into half. So it will be 2 seconds. So torque will be 2 seconds. So similar questions, sometimes it may be like this. Here, suppose same questions, you just see the difference. In which part you have to do integration and differentiation, that part you must know. Suppose here given normal formula dl by dt. Okay. So suppose angular momentum, it is given this one. Suppose you have given torque. Suppose one more question. Torque acting, that means torque tau is equal to twice square Newton meter on a body. So torque acting tau is equal to 2t square Newton meter on a body. So after acting, so what will be the angular momentum? What will be the angular momentum? So you just recall the formula. So what is the formula? Already I have given tau is equal to I have given tau is equal to dl divided by dt. Solution. So in this case here torque is given. The value of torque is given. Torque it is given. What is the value of torque? It is given 2t square only is equal to dl divided by dt implies dl is equal to 2t square dt. In this case integrating both sides. So after integration we can write L is equal to 4t. So here it will be 2 outside and it will be 3 by 3. So here time interval should be given. So suppose time interval, what will be the angular momentum for the time interval 0 to 1 second. So here given 0 to 1 second. So that is why it will be 0, 1, 0, 1. Now in this case it will be written as 2 by 3 into 1 cube minus 0 cube like this. So ultimately 2 by 3 is the correct answer. So L is equal to 2 by 3. L is equal to 2 by 3 is the correct option. So therefore the angular momentum of a particle can be expressed in terms of L, and which is represent here 2 by 3 unit will be L is equal to rp. So kg meter square per second. Kg meter square per second is the answer of the angular momentum. Now see one more question here. Moment of inertia. So what is the meaning of moment of inertia? Moment of inertia means it is the product of mass of a body and the square distance from the center of rotation. Suppose if we consider moment of inertia, we are talking about moment of inertia. Moment of inertia, that means I. We are talking about moment of inertia I. So I means it is mr square. So how we can define? It is the product of mass and square distance from the axis of rotation. So I is equal to mr square. That means the product of mass and square distance from the axis of rotation. Then it is called moment of inertia. And this moment of inertia, it is expressed kg meter square. So what is the dimension of the moment of inertia? So dimension will be m L square. So we can write t to the power 0 also. So this is the dimension of moment of inertia. So moment of inertia we can express in terms of kg meter square, and the dimension will be ml square t to the power 0. So in this case, you always remember, depending upon the questions, we have to proceed and we have to use this particular formula. That is why from the beginning, whatever formula is given, you have to memorize all the formula, and you have to practice the formula, and you have to rewrite again and again. Then only it will store in your memory. Then you can use for solving the numericals problem. So that is why this is the part of the chapter. Basically, this is a short revision of the chapter motion, laws of motion, and their applications. So motion, basically it is related with the Newton's law of motions, first law, second law, and third law. Already you got in class 9. Only here some application is more. And one more things here, this is a very important topic which is I already have discussed, recoil velocity. So related to the formula, sometimes numericals will come. So recoil velocity also important. So dimensions, you have to recall all the previous classes. You have to see previous classes. That means the basics of physics you must know. So after knowing the basics of physics, you can easily do, or you can easily solve the numericals problem, because physics is basically based on the principle of mathematics. So that is why the mathematicals basics of maths is very important. So after knowing all the mathematical, that means integration, differentiation, then you can apply and you can easily solve the numericals. It will be easy for you. So now in this case, normally the laws of motion, it is Newton's law of motion, inertia. That means some basic questions may be asked to you, that how the inertia is related with the rest body and motional body. So already you know the inertia, basically it is the tendency of the rest and motion, tendency of the body. That means a rest body always try to in at rest position, and the motional body always try to get in motion. So this is the example of inertia and their properties. So today I want to stop, and you always practice, because numericals short revision already I have given. Only you have to use the formula which is already I have given today, and using this formula you can easily solve all the numericals depending upon the questions. Thank you.